Here we are. Okay, so after you get all the loads for the columns checked, it's time for you to design the columns for real. And generally, if you look at the plan, I should try to revisit the plan again. Not this one, sorry. I was thinking about looking at it, but then I changed my mind, and I changed my mind once more. Okay, so is it clean enough, this one? Okay, so if you look at the roof, generally I say I will only ask you to design the 2 columns, but the way they run their names, it's a bit difficult for me to, yeah, you can do that, okay? You don't have to use the same name as the columns shown in the drawings, but generally if it is my own work, I would name the columns at the same location with the same names. However, doesn't seem to be the case here, so I will not argue with that. Okay. However, let's say the column size here is the same. Okay, because look at the geometry of the roof load. It is carrying the same load. So that's why they call this one C2. Okay, and ladies and gentlemen, I am not asking you to design like 2 sides, because this one may be different from that. So after the load summation, you can just use the most critical one, which is this, because the tributary area is this. All right. Therefore, just design this column. Okay. And because you have a small columns on only a few locations, this one will be slightly smaller, and that one is smaller, and that one perhaps. So, generally it is not bad economy to use the same size in this case, because it's only a few of them that will carry a less load. So in this case, you design 1 column for the roof. Okay. And now we are down to this. Now they use the 2 sets of columns here. They have the C3, and then they have the C3, the same one. Then they have the C1, and then they have the C1. So that means you would have the 2 sets of different columns, okay? And we will deal with, you see, there's a one that in between the 2 zones, the 2 different live load zones. So for this one, you use the same size as the ones in the heavier live load zone, okay? So it should be that simple. According to this drawing, they are saying that they use the same size of the column for this one and that one. I want you to check the load that you have and say if you can do that. If you can do that, and the 2 different loads give you the same size of the column after you design it, well, I suppose you can use the same. If not, you need to consider using differently. Okay, and for this, it's just the same business. Okay, check the load on both sides and see if you can use the same size of the column. Okay, so I'm trying to stick to what the drawings say. So that means you are going to design 3 sizes of the columns. So let me try to write it down for you. I am, so let's say from the roof, if I try to draw a 3D problem, this is your frame, and you have the column C2, right, for the roof. And then this will be the tributary area. For one side, and then, you know, the same tributary area for C2 on the opposite side. So this is the from roof to second floor. So from roof to second floor, these columns are carrying the roof. Okay, and then you go down to the columns from second floor to ground. So this column will carry the load from, you know, C2 up top and the second floor. Okay, and this you have C1 and C3, C1 and C3, depending on which zone you are at. So you need to, you know, check the load, design it, and see if the same size can be used. Okay, generally before we engineers design the sizes of the members, we would look at the load and try to group the load. For example, there must have been a good reason that they use the same name on both sides, you know, because you have done the analysis. I haven't looked at your results and say if the loads are not too different, you say, okay, the loads are pretty much the same, so I'm just going to pick the most critical one, which is going to be only slightly more than the other one, and then design my column for that. And you do the same for C1 and then for C3. Okay, generally you can stick to this detail, and in the end you can say, okay, my C1 is going to be H blah 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 blah, my C2 H blah 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 blah, and my C3 H blah 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 blah. But if it was my own work, I would prefer to name, say, the column on one grid by one name. I myself wouldn't change the name from this to C2 to C1. I would call it C1, and I would give detail that C1 from roof to second floor is this member, and from second floor to ground is this member. But then again, I can understand why the final design is like this, because on this side, this is not continuous. So to have a continuous on one side, and then again on this side, they have to change the name. So they'd rather do this to accommodate the final design. You know what I mean? So this is what you would do. You have the load and you have my design tables. You can just look at your unbraced length and say, approximate column size by using K equal to 1, and then you can go to my design table with the unbraced length KL and pick the column. That's it. Don't forget to check the local buckling once you have your section. Okay, I don't remember if I have ever mentioned what steel you should use. So I think you are free to use SS400 or SM500. It's entirely up to you, but you can choose either of them, choose either. But use only one. Okay, that means if you decide to use SM520, you use SM520 columns for the entire, for every column section. Okay, you don't, okay, C1 I'm going to use SS400, and then C3 I'm going to use SM520. Don't do that, because in the real world it will be impossible to construct. All right, it will be quite confusing. And this is for your column. And for your truss, once you know the load, okay, you're free to choose whatever your configuration is. Okay, I think we have like 6 meters, right? You are going to have 5 panels, because I'd say we have 5 purlin at every 1.2 meters, right? So you have the load of the purlin coming down here. So you need to have the panel of the truss here to support the point load. Okay, and be careful, your top cord is going to be under tension, right? And your bottom cord is going to be under compression. Okay, you know, I have drawn a slightly slant truss like this, because on top it has to be 6, but this one you can just bring it down here. It doesn't have to go out at the, you know, to support the end. Okay, and use the tube section. Okay, unfortunately for tube section, we don't have the tables. I only have the tables for H. So you're gonna have to do a little bit of a trial error for yourself. You may try to treat your compression with the, you know, the unbraced length that I have taught you, but since this is the tube section, so, you know, the KL, the unbraced length KL on either axis will be the same. So you may choose to check this one, you know, with the entire length, and the K is equal to 0.6 or 65. You better check that again. And then the shorter one, you know, in plane, it's going to be shorter and K equal to 1. So that will be more critical. Okay. And be careful that grade for the tube is different from SS400 and 520, SM520. Okay, they have like TIS 107, which has like FY equal to 2400, and then they have some other things. You know, they have like 3 grades, but I don't remember them all. Be careful that you use the right grade when you calculate. Okay. To use the wrong yield strength would be fatal. If you want to be an engineer and you don't know the materials you are going to use, that is unacceptable. Okay. So use this one. So you only need to figure out the one critical unbraced length. Use that for your design. Come up with your member. Okay, so that is the end of the truss. Now, one more thing that you can proceed to do is that you would know the final load here. Okay, there's a final load, the maximum load. So you can also, let me design the base plate. So because you may have C1 and C3. So for your base plate, you should design at least 2 base plates. Okay. Now, do you know how to design the column now? The RC column? Hello?
Not yet.
Not yet. So
Yes.
we need to have the column size to be able to design the base plate. Okay. I undecided whether to give you the column size big enough so that you can use a factor 2, or so let's say RC, the column, the underneath the ground, it called it abutment. Okay, RC abutment size for now it is pending. Okay, let me make a final decision. And FC prime that you can use to check the concrete crushing, you can pick 240 or 280. 280 is becoming very, very common right now. So you may want to go for 280, but 240 is fine as well. Okay. And that is it about the design of the columns. It should be straightforward enough. And if you get what you need to do, the column design should be done in like maybe 10 minutes or so. This guy will take a little more time because you don't have the table. So you need to do some try and error before you get the right section. Okay. And that shouldn't be long if you have your load back. And I will sort out the size of the base plate. Okay. So that's it for the phase number 3. You are going to design the 3 columns. Okay, and then the truss member. Oh, don't forget that you also need to design your diagonal and vertical web if you have any. All right. Don't forget your web. And for the compression member, it's easy because K is equal to 1 and the length will be just the length of the member, the unbraced length. Okay, and for tension member, it's just so straightforward. You just pick based on the yielding and rupture. Okay. You need to design your top chord as well. Don't forget that. Okay. All right. Is there any question? Okay. I will stop the share first. And I will stop the record too.